Welcome back to Mustang Physics. Hey, if you haven't watched our video about electromagnets, go watch that first and then come back. This is our video about motors and speakers. Now, this doesn't really look like a motor or a speaker, but it might be the most important demo you're going to see of the four today. This is simply a wire connected to a battery, so it looks like an electromagnet, and it is. This button will connect these two wires so that a complete circuit can be made, and you'll see if I press it that the wire doesn't look to do anything. There's a magnetic field around the wire when current flows through it, but we can't see it. Magnetic fields don't visually identify themselves. And this is where we have to go beyond the fact that there is an electromagnet and start thinking about electromagnets in a little bit more detail. One of the more important things that we know about magnets is that they can exert a force on each other. And if one of those things is an electromagnet, we can control that force to a certain extent. So here's our old friend, the neodymium magnets from the permanent magnets video. And you can see that if I put it near the wire, that it does not affect the wire. But if I have it near the wire when I run current through the wire, you can see that the wire moves over towards it. And if I reverse the permanent magnet, when I run current through the wire moves away. There we go. Now, there we go. So I can control the force on the wire and make it towards or away from another permanent magnet, depending on the direction that I run current through the wire or depending on the direction of the permanent magnet. Now, in motors and speakers, it's much easier to reverse the direction of the current in the wire. But essentially, what we've just demonstrated is the physics behind both motors and speakers. If you have an electromagnet and some other magnet, maybe it's another permanent magnet, maybe it's a second electromagnet, and you can get them nearby each other, they can push or pull on each other. So let's talk about how a speaker is built. A speaker is simply a coiled wire that is nested deep inside of a cone. So we've got a diagram of the speaker here, and then I've got an actual speaker here. The magnet assembly is always at the back of the speaker, and then you cannot see the voice coil. That is the loop of wire that carries current. And if you could see it, you would see it down in here, connected to the back of the cone behind this spider. This spider is simply a suspension that keeps the speaker from sloshing around sideways as it moves in and out. If you have a blown speaker, it's because the voice coil is rubbing that on the inside of the magnet structure. That oftentimes happens when you run too much current through the wire. Now, the cone itself and the surround, that's just the part of the speaker that actually pushes on the air, but getting it, of course, to vibrate in and out is the key. So that's where we use this idea that we saw in the first demo, that two magnets can exert a force on each other. So I've got one magnet, I need to have a second magnet, and so that voice coil that's nested deep inside, I'm going to run current through that coil. So you can see that there are electrical inputs here, as there are on all speakers. And I've got that electrical input hooked up to a frequency generator. Now, right now I've got it set at 9 hertz with no amplitude, so I'm not running any current. Well, let's take a look at what happens if I turn up the current. By increasing the current through the voice coil, now you can see that our speaker cone is vibrating. By adjusting the frequency at which the voice coil gets current, we can adjust how often the speaker vibrates in and out. Now, interestingly enough, the camera also has a frequency at which it takes pictures, and those frequencies sometimes interfere, so it makes it look like the speaker's sitting still or vibrating at a frequency that's a little different than what's displayed. That's vibrating slow enough that we can see that it's going in and out. Really then, to make the speaker do that, we just have to make sure that the cone is repelled from, that's what makes it push out, and then attracted to, that makes it go back in, the permanent magnet. And that's really done behind the scenes. So if we go back to the notes here a little bit, the reason that that speaker is going in and out is actually what's going on back here. the current in the coil is going one way, then the other, then one way, then the other, which causes it to be attracted and then repelled and then attracted and repelled from this magnet. To make it make much higher frequency sounds, we just need to reverse the current much more often. And if we reverse the current often enough, it gets into our audible range. And we can start to hear it. Now, those sounds don't require the cone to move as much. The higher the frequency, the less the cone really has to move to vibrate the air in that way. And so that's why you're not seeing the cone move once we get up into those higher frequencies. So a speaker, just an electromagnet and a permanent magnet nearby, and we drive the current in the voice coil in a particular direction with a particular strength to make it either attract or repel from the magnet, so that that causes a force on the cone to make it vibrate back and forth. Now, for those of you who want to know a little bit more about that, here's some other things that you could go out into the world and think about. For our class right now, magnetically, we certainly want you to understand the things that affect how the speaker functions. And the number one is, how close are the voice coil and the magnet? The reason I couldn't show you the voice coil inside of here is because it's always nested right next to the magnet, because magnetic fields, kind of like static electricity, don't really have much of an effect at a long distance. The distance is really crucial to how efficient the speaker is. The amount of current through the voice coil is what makes it louder. That's what you're doing when you turn up your stereo. The strength of the magnet itself, that's this magnet here, affects the sound. If this magnet's stronger, you get more force between it and the magnetic field in the voice coil. That really is a part of when you buy the speaker, how it was built and how it was engineered. And finally, the length of the wire in the voice coil, that affects the amount of magnetic field made by the voice coil. Now, acoustically, how rigid this cone is and how massive this cone is, the more massive it is, the more likely to make low frequency sounds better than high frequency sounds. What the box is around the speaker, this speaker's not very loud because air from the front and the back isn't separated. That's why every speaker comes in a box. All of those things affect acoustically what a particular speaker will sound like. I used to sell electronics, so I'll give you this piece of advice. If you're wanting to go buy a speaker, go listen to that speaker before you buy it. No description of it can really do it justice. Now, enough about speakers. Let's talk about motors. Motors are ever present, from whether we're talking about the thing that makes your phone vibrate, that's a motor with a weight attached off center, or the thing that runs your vacuum cleaner, or if you have an electric car, the thing that makes your electric car move. So another application of that first rule of magnetism is a motor, and you can see it's really just a wire near a permanent magnet, which is a lot like a speaker. Only in the case of a motor, what we're trying to do is cause rotation rather than vibration back and forth. So this is like an exploded motor. It doesn't work. It's not really great to look at, or it's not really great to power anything, but it's good for thinking about how they work. You can see the things that influence how powerful the motor are really very similar to what affects how loud a speaker can get. And that's because magnetically, they're the same. You've got an electromagnet, and then where my fingers are, if this were a working motor, there'd be permanent magnets. If we could run current through this loop of wire in the right direction so that it would repel the permanent magnets where my fingers are, that would cause the motor to turn. Now, just a little bit different from a speaker, because this turns, we can't hardwire the electromagnet to current. And that's what this device is about. This is a brush, and this is a commutator. And if we zoom way in, there we go. You can see that it's just a metal connection that's just resting on top of it. That way, the brush and the commutator can slide by each other. And when this piece of metal here and this piece of metal here touch, current can flow from this wire down through that structure, the brush and the commutator, down to this armature, which is basically just an electromagnet. A genuine motor would be built much tighter. This is a motor out of a vacuum cleaner. And so here's the commutator. The brushes would have been here, but we've taken them out so you can see them. And you can see that there are, let me zoom way back out a little bit here. There we go. You can see there are tons of loops of wire in here. And those loops of wire would be turned on 2 at a time. You can see that there's lots of little cuts in this commutator, so electricity would flow through a couple of different loops at any one time as the motor spins like this. The loops of wire that would have current running through them are the ones that are close to these loops of wire on the outside. So this magnet uses electromagnets only. The current running in these electromagnets would cause a magnetic field that faces in the right direction, so that the current running in these electromagnets would be repelled, and that's what causes them to push away and then to turn. And then on the output shaft, we just attach whatever it is we want to drive. So a motor like this could be used to drive a wheel. It could be used to drive the fan that drives a vacuum cleaner. It could be used to drive anything that we want to turn. All right. Hope you've enjoyed this video about motors and speakers. See you next time.